Hello, I am Albert Jantulop and today I am going to present my midterm examination video in parallel and distributed systems. These are the topics that I will discuss. Now let's go to the first one. Imagine having the need to process an intensive data and complex computations in a single computer. Even if you just think about it, it will surely bring up a question of how does a single computer handle that kind of processes. Well, that's what it's like back then when distributed system is not yet being implemented. Instead of using a centralized computer to solve computational problems, a parallel and distributed system or computing system uses multiple computers to solve large-scale problems over the internet. The distribution system is a set of interconnected autonomous computers that cooperatively solve large single problems or facilitate parallel execution of separate but possibly related tasks. It is like a network, but in this case, that network is hidden and appears as a single computer, but it really is a multiple computers that communicate with each other to process incoming requests. Distributed systems also has the characteristics of resource sharing, openness, concurrency, scalability, fault tolerance, and lastly, transparency. Now let's go to the discussion of architecture of clouds and Internet of Things. Back in 1990s, the use of both HPC or high performance computing and high throughput computing or HTC systems has rapidly increased. It is to leverage the evolution of HPC and HTC systems. Uh, Supercomputers in HPC systems are being replaced by a cluster of cooperative computers here, having the desire to share computing resources. These cooperative computers are a collection of homogeneous computing nodes that are physically connected to one another in a close-range setup. In HTC systems, P2P networks have been formed for distributed file sharing and content delivery applications. P2P, as we know, is built over many client machines. Like the ones we know in networking, P2P, cloud computing, and web service platforms, those technologies are more focused on HTC applications than HPC applications. Both clustering and P2P technologies evolved to the development of computational data grids. After the age of computational data grids, service-oriented architecture or SOA emerged and Web 2.0 services became available. Developments also in virtualization also took a leap and made it possible to see the growth of internet clouds as a new computing paradigm. And the Internet of Things development was pushed by the maturity of RFID and GPS or and other sensor technologies. Now let's go to the interconnection networks. An interconnection network in a parallel machine transfers information from any source node to any desired destination node. This task should be completed with as small latency as possible. It should allow a large number of such transfers to take place concurrently. Interconnection networks are composed of switching elements. Topology is the pattern to connect the individual switches to other elements like processors, memories, and any other hardware resources. A network allows exchange of data between processors in the parallel systems. This figure is about three interconnection networks for connecting servers, client host, and storage devices. First, LAN connects the client, host, and servers, and the SAN connects servers with desk arrays. And lastly, NAS connects clients and large storage systems in network environment. Lastly, let's talk about the difference between traditional computer and virtual machines. Before we dive right in, the differences between the two, let's first talk about them individually. What is traditional computer and virtual machine? First, traditional computer is what our computer physically looks like. It is the computer itself with its peripherals and how we use it purely as it is. Virtual machines, on the other hand, is like the machine within a machine. It is confusing at first, but you just need to imagine a kid playing bahay-bahayan inside its house. With that analogy, we can say that the traditional computer is the house itself, while the virtual machines is the mini house that the kid built inside its real house. Now, what's the need for virtual machine, especially in the field of parallel and distributed computing? It is because it represents a great opportunity for parallel, cluster, grid, cloud, and distributed computing. Virtualization technology benefits the computer and IT industries by enabling users to share expensive hardware resources by multiplexing virtual machines on the same set of hardware hosts. In virtualization, it is to separate the hardware from the software to yield better system efficiency. There are also different levels of virtualization, and we're going to discuss. That are namely first application level, library level, operating system level, hardware abstraction layer level, and lastly instruction set architecture level. First, the architecture application level. If you wish to virtualize an application, this is where user application level comes handy. It is because it does not virtualize an entire platform or environment. Programs written in high-level languages and compiled for an application level virtual machine can run fluently here. Second one, library support level. API hooks makes the library interfacing virtualization possible. What they do is that the API controls the communication link from the system to the applications. Most of the APIs provided by systems are rather well documented. Hence, library level virtualization is preferred in such scenarios. Next is operating system level. In this level, an abstract layer between the applications and the OS is existing. It is like an isolated container of the on the physical server and operating system that utilizes hardware and software. Each of these containers functions like servers. There are also personal environment for every user in this level with dedicated virtual hardware resources. Fourth one is a hardware abstraction layer level. This level helps form the virtual machine and manages the hardware through virtualization. It does not it enables virtualization on each hardware components such as input-output devices, processors, memories, and etc. This way, multiple users can use the same hardware with numerous instances of virtualization at the same time. And lastly, the instruction set level, virtualization through the use of ISA emulation, binary code that needs another additional layer just to implement can now run on x86 machine and also in x64 machine through a little configuration. Basic emulation requires an interpreter that interprets the source code and will convert it to a hardware readable format. Now, what is the difference between the two? First, the cost. Usage of a traditional computer may increase the cost in terms of having the to multiple instances multiple instances of the machine itself, and having multiple machines just to satisfy that need will cost you so much. This is where virtualization comes in. One of the main reasons why it boomed is because its capabilities to run multiple instances in the same machine. Second, the security you have when using virtual machines is much more higher than using just the traditional machines. It is because usually when you're using VMs, the risk is just the in the machines itself, removing the risk for the physical machine to be damaged and harmed. While on the other hand, the traditional computer can be easily penetrated and get harmed compared to the virtual machines. Lastly, and third, the control in virtual machines comes more with more utilities than the traditional computer itself, like having to control a specific software that runs on your VM or on your virtual machine. The level of configuration is much more higher than the machine itself. As you can see here in the illustration on the left side, is a traditional computer that is purely the hardware OS application structure, as you can see here. But on the right side is the virtual after the virtualization, having the hardware virtualization layer and virtual machines. You can see here that the traditional computer utilizes its own resources purely, while on the other one, after visualization, uh, utilizes its resources to have more machines. Like you can see here, there are two virtual machines within the same machine. So here are the references that I've used for this video. It is a PDF of the book, and that's it. Thank you for listening, and have a nice day.